So good afternoon, students. And today we will be continuing with the chapter motion, which we were doing. And till our last class, we have done the distance time graph, the velocity time graph. And now today we will be doing one of the very important topic, that is the equation of motion by the graphical method. We will deduce the three types of equations, which are the equations of motions. So here, first of all, when a body is moving along a straight line with a uniform acceleration, we can establish relationship between the velocity of the body, acceleration, and the distance traveled by the body. Okay, so first of all, we all know that suppose in general way, when we were representing the initial velocity, with what abbreviation we were representing the initial velocity, students? Can you remember? Just tell me so that I can unmute you. Suppose we are going to represent the velocity of the body, the acceleration and the distance. So with what abbreviations we were representing the initial velocity? Okay, Shripati, unmute yourself. Okay, Jyoti raised her hand. Okay, first Jyoti. Okay, Jyoti.
Sir, by U.
By U. Very good. And
Small.
we are representing the final velocity by Shripati. We are representing the final velocity by what abbreviation? Okay.
V.
V. Okay, fine. Yes, Safia also raised her hand. Let me allow Safia also, as she has raised her hand. Safia, you can unmute yourself. Okay. Okay, by V. Correct. And the acceleration we are representing by, okay, Pratyush of 9C. Unmute yourself, Pratyush. Pratyush of 9C. Yes, Pratyush. I think audibility. Okay, no problem. Yes, the acceleration we are representing by A. Now, the relationship between the three, that what we are saying, we can represent by a set of equation, which is called equation of motion. So what is the equation of motion? When a body is moving in a straight line with a uniform acceleration, definitely we can establish a relationship between the velocity of the body, acceleration, and the distance traveled by in a particular time by a set of equation, which is called the equation of motion. And in all, there are three equations of motion. You can see on the screen also. Equation of motion, there are three equations of motion. First is V is equals to U plus AT. The second one is S is equals to UT plus half AT square. And the third one is V square minus U square is equals to 2AS. And what does the abbreviation here represent? That I have already asked you all. That was U is the initial velocity at time, when time is 0. Small a is the uniform acceleration of the body, and V is the final velocity of the body after 30 seconds, and S is the distance covered. Now here one thing to be noted, student, when we will be talking about equation 1, the equation 1 represents the velocity time relation. Okay, it represents or it symbolizes velocity time relation. Equation 2, S is equals to UT plus half AT square, represents position time relation. And equation 3, v square minus u square is equals to 2as represents position velocity relation. So these three are the cases, or we can say the three questions which we are going to discuss. So all of you have understood the introductory part? All of you have understood the introductory part? Yes or no? All the students give me the reply through the chat box. The introductory part I am asking, and one by one now we will be going to do the three equations of motion. Yes, students of 9C, you also respond, and I hope students of 9C, okay. Yes, Aditya of 9C, is it clear, Aditya? Through the chat box, you give me the reply. Aditya 9C, okay. Okay, fine, Aditya, I got the reply. Okay, now students, we will be discussing the equation of motion. First, we will be discussing how we can derive V is equals to U plus AT. Now for this, all of you look to the diagram, the graph. Okay. After doing, student, the velocity time graph, I think now it must be very clear to you all that what we are plotting on the x-axis, what we are plotting on the y-axis. Okay, so here on the y-axis, we have plotted the velocity. On the x-axis, we have plotted the time. And now see how we are moving ahead. So suppose a body is moving along a straight line with a uniform acceleration A. Let U be the initial velocity at the time 0. The velocity time graph for such a body is represented by a straight line. This you all know, we have already discussed in the class, that when a body is moving with a uniform acceleration, then definitely then what will be the nature of the graph? The nature of the graph will be a straight line as indicated in the image. As indicated in the image, the nature of the graph is a straight line. The straight line is indicated by AB. Okay, this is the nature of the graph. Now see what we have to deduce from here. At time t0, velocity OA, this part, velocity OA is equals to the initial velocity U. OA is equals to U. Do you agree? Through the chat box, you immediately respond to me, yes or no. Okay, I will see the chat box parallelly so that I can get the idea that yes, the things are getting clear to you. Please respond through the chat box, yes or no, quickly. At the time 0, when the initial velocity is definitely the OA, okay, and OA we can represent by U, which is the initial velocity. Now see what is happening. Now, in moving from the particle, or we can say the body is moving, in going from A to B, the particle is moving from A to B, the velocity goes on increasing at a constant rate, at a constant rate, that is the acceleration. That means this is the positive acceleration. Okay, this is the that means it is a one thing here, the acceleration, as we are saying about, it is a uniform, and here a acceleration, and at t, at the time t is equals to OC, the velocity is CB, this part, and which is equals to the final velocity V. So we can say that at t0, OA means the initial velocity, which is represented by U, and CB represents the final velocity, which is represented by U. Did you got this, students? The initial velocity and the final velocity, which I have just discussed now. that OA represents the initial velocity and CB represents the final velocity. Immediately through the chat box, student, give me the reply. Okay, I got reply from Anupam. I'm waiting for your responses, students, so that I will progress further. Okay, Shripati said once again to repeat for this. Okay, 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 no problem, students. Okay. Acha, Jyoti said Sri Biko. No, Jyoti, we have to take into account parallel to the y-axis. Okay, parallel to the y-axis. Okay. Now see, once again. Okay. That's why I'm asking you in between. See, at the time, when the time is 0, we can't say that OA is the initial velocity. U, is it, Shripati? One by one, I'm making the points clear. Can't we say OA to be the initial velocity? Yes or no? Okay. Shripati, I'm waiting for your response also. Okay. And at the time T, okay, that means the OC, can't we say that CB is the final velocity, which is V? Yes or no, Shripati? Now it is clear. Now it is clear, Shripati. Okay, and Jyoti, is it clear to you now? Okay, fine. Okay, so now these 2 points we will keep in our mind, that OA is the initial velocity and CB is the final velocity. Now see, now draw AD perpendicular to BC. That means we will draw now another line. This is represented by the dotted line. We will draw AD, which is perpendicular to the line BC. Okay, and now we will draw another line BE, which is perpendicular to OY. Got it, students? So 2 lines we are drawing perpendicular. One is AD perpendicular to BC and other is BE perpendicular to OY. Is it clear? Is it clear to all? Student, that we are considering at a point, Shripati. Okay, we are considering it as a point. Okay. Is it clear, Shripati? Okay. Okay. Just a moment. Okay. Yes, students. Just a moment. Okay. Yes, I got the response. So now all of you see, it is known that the acceleration of the body is equals to the slope of the velocity time graph. This already during today offline class also we have done. That is the slope of the velocity time graph is the acceleration. So acceleration A is equals to the tan theta, and tan theta, you know, perpendicular by base, that is BD by AD. Did you got it? So BD, this is BD and this is AD. So tan theta is equals to BD by AD. Now BD, now here let me clear the drawing. Now BD is equals to, as we have already done, can you tell me, student, as we have already done in today's class, BD definitely, if we want to get BD, we have to minus BC minus CD. Is it or not? So now when we are doing this subtraction, BD, yes, correct. So now you are getting the BD is equals to BC minus CD. Now CD is equals to OA. Definitely this is equal. CD is equals to, student, keep on seeing my screen, okay? I am working with the graph. This OA and CD, this is equals to, okay? So now BD is equals to BC. Now see, BC is equals to V, yes or no? Because that is a final velocity. BC is equals to V because that is a final velocity, and OA is your initial velocity. So V minus U is equals to change in velocity. That means the final minus initial velocity. That means the change in velocity. And now AD, all of you look to the graph, AD is equals to OC is equals to time T. So from equation, this one where we have said A equals to BD by AD, we will now put the value of AD, value of, now we are putting the value of first BD we have got V minus U and time is T. So V minus U is equals to AT, therefore V is equals to U plus AT. Is it clear to all? Is it clear to all the students? Please, through the chat box, you give me the reply. Through the chat box, you give me the reply. I'm waiting for your reply and then I will proceed further. Okay, maximum of you have said yes, and few students have shown okay. All the student near about. Okay, Shripati has some doubts. Shripati, can you, okay, Shripati, I'm unmuting you. You kindly tell me your doubt. No need to write in the chat box. Now you unmute yourself to share your doubt.
सर आप जो अभी मतलब कि बताया ना कि A इक्वल टू tan थीटा BD by AD, सर वो वाला सर थोड़ा सा समझ में नहीं आ रहा है.
Okay, okay, Shripati. Okay, I'm muting you. फिर से मैं बताता हूँ. Okay, Shripati. See, Shripati, again that point of the class when we were sharing. Let me clear this diagram. See, consider this triangle. Shripati, consider this triangle BAD. Consider this triangle. Now, tan theta is equals to BD, that is perpendicular by base. So which is the perpendicular? BD and the base is AD. Okay, so BD by AD. This is the formula. Is it clear now, Shripati? Shripati, you can unmute yourself. You can directly talk with me.
Yes, sir, it is clear now.
Okay. Any more doubts, Shripati? Shripati, any more doubts? Yes, Shripati, any more doubts? Okay, through
No,
the chat.
sir.
Okay, okay, Shripati. Okay. Take. Okay. Yes, I'm individually also asking to all the students. Yes, now, yes, all the students have given the reply. So this equation we have derived. Now we will be coming to the next velocity time equation. See, student, now to get the second equation, that is S is equals to UT plus half AT square. Okay, the position time relation. Now we will consider the figure. And student, you can remember in the class also, when we have said the position time relation, we have said the area of the rectangle plus the area of the triangle. Okay. Okay. Yes, Aditya, if you have any doubts, you can send in the chat box also. Just a moment. So students, to get the second equation, we have to see list. Yes. Now this will be, just a moment. Now here the distance S is the area of the figure OABC. And now in this area, you have one rectangle. That is the area. What is the rectangle? OADC plus area of the triangle BAD. So if we will sum up their area, then we can get the distance traveled by the body. Did you got it? And now how we will get this? Already in the offline class also, I told you that how you will calculate the area of OA, that is a rectangle, and how the area of the triangle can be calculated, though I will be doing once again. But I hope now you have understood one thing. Just a moment. I hope now you have understood one thing. That is how we can calculate the area for this. Now see how we will be doing this. Till this is clear to all. The distance traveled by the particle must be equal to the area of the rectangle plus the area of the triangle. Is it clear? I want the feedback from all the students. Okay, yes, Jyoti said clear. Okay, just a moment. Shripati said yes, sir. Okay. Okay, yes. Okay, fine. Yes. Okay. Now we will calculate the area of the rectangle. Area of the rectangle, length into breadth. So if we are saying this to be the triangle, this to be the rectangle, then you can see, let me use the, let me first reduce the size of the page. Yes, you can see over here, student, this is your rectangle, length into breadth. Okay, so now what we will be doing, either OA into AC, okay, that we are doing over here, OADC. So now we will be calculating it, OA into AC, and now half into area of the triangle BD into AD, that is perpendicular and the base. So this is the formula. This formula already in the today's class also we have done. And now we will be moving towards, now we will put the values. Okay, now we will put the value, student. OA into AC, that is equal to the initial velocity U into T, and BD. BD definitely, again, we are coming to the same point. BD will be BC minus CD, and AD definitely will be equivalent to OC. Now again, S, BC, CD is equivalent to OA into OC, and now put the values. We know BC is equals to B, OA is equals to U. Therefore, we know acceleration B minus U by T. And now in this above equation, if we'll put all the values, then we are getting this directly, student. This we have already done today in the offline class also. You can remember during the offline class also, when we were calculating the area, the distance covered from the graph. I'm also showing you the same graph which we have discussed in today's class also. The same formula we are keeping over here, only the values we are putting over here. Yes, you can remember, student, this graph which we have done. It is the same. The formula is the same. Okay. And we have put the values over here simply to get. You have to remember, student, very carefully these parts. That is the how we will be calculating the BD. Then CD is equals to OA. Again, I'm showing you the same figure. CD. See, I'm showing you once again. CD is equals to OA. This is also the same, and hence we are getting this equation. Is it clear to you now? The second equation. And 1 minute. Now the second equation is clear to all. Yes, Aditya, very good. Yes, definitely, Aditya. We can use the area of trapezium. Yes, very good, Aditya. We can definitely use the area of the trapezium also. Directly also we can do that. Okay, now we are coming to the last one, which is again the last one. As Aditya also, can we use the area of the trapezium? So the distance traveled by the uniformly accelerated body, students, once accelerated body in the time t is given by the area enclosed in the space between the velocity time graph and the time axis. Definitely the area of the trapezium OABC. See the trapezium OABC. So this area, for this again we are coming back to, I'm showing you, coming back to the diagram. Area of the trapezium, how we'll get sum of parallel sides divided by 2 into the distance between the parallel side. Yes, Siddhant has given the formula also. So sum of the parallel side, which are the parallel side? OA, OA and CB. These are the parallel side. OA and CB is the parallel side, this whole area. So here, now we are doing the sum of the parallel side. That is OA plus CB, and distance between the parallel side. The distance between the parallel side, definitely it's OC. You can see the x-axis, the distance between the parallel. You see arrow OC. So now you are getting here OA plus CB. We all know the value U plus V, because OA is the initial velocity and CB is the final velocity, and OC is the time. And we all know V is equals to U plus 80. Put the value of V over there. And now we can get the value of T also over here. So S is equals to V plus U by 2. And now put the value simply, we will get V minus U square is equals to 2A. This is very simple. Only we have to remember the area of the trapezium, that is half into the parallel sides and the distance between the parallel sides. And we are knowing the value of OA is equals to U, and we are knowing the value of T also. So simply T we are putting over there to get the value, and then simply by putting the value of the T in the above equation, here students see value of T we are getting over there, and now this value of T we are putting in this equation. So we are getting finally this equation. And last we are with the proof that V minus U square is equals to 2AS. Is it clear to all the students? Is it clear to all the students? Through the chat box, you give me the reply. Okay. Yes, I want the feedback from all the students. Okay, GIS. Okay, fine. Yes, definitely, students. When you will write the same, then it will be yes, it will be more getting imprinted on your mind. Definitely, it's correct. Okay.